Hello. Let us understand gravitation. In this tutorial, we will study about universal law of gravitation, the gravity near the Earth's surface, the motion of the planets around the Sun, that is Kepler's law, and the importance of law of gravitation. Newton, apart from formulating the three laws of motion, he also examined the motion of celestial bodies, and he concluded that every object whichever is on the surface of the earth is attracted by the earth towards its center. Now if there is an object on the surface of the earth over here, now this object is always attracted by the earth towards its center. If C is a center over here, the force exerted by the earth, it varies inversely as a square of its distance and varies directly as the mass of the object. Now the object is over here. The force that is exerted by the earth in pulling this object towards its center, okay, it varies inversely as the square of the distance. That is, if distance is given by d, it varies square of its distance and is directly proportional to the mass of the object on the surface. Newton also generalized that there exists force between two objects. If there is an object 1 and object 2 over here, now there is a force between the two objects F1 and F2. So we can say that force is directly proportional to the product of the masses, that is m1 and m2, and it is inversely proportional to the square of its distance, which is either given by r or it could be given by d also. Now finally we can say that force F is equal to we can say F of g is equal to gravitational force is equal to m1 into m2, that is the product of the masses, divided by r square. This is nothing but the distance between the objects, where g is the gravitational constant. The value of the g is this. Now let us try and understand the concept of universal law of gravitation. The universal law of gravitation, it states that every particle in the universe, you take any particle in the universe, it attracts every other particle. For example, F1 and F2 are two particles in the universe. They attract each other with a force. Now this force is proportional to the product of the masses and it is inversely proportional to the square of the distance between them. So F is nothing but is directly proportional to the product of the masses, that is m1 and m2, and it is inversely proportional to the square of the distance between them. Now we can see it over here. Now in this case, the moon is rotating around the earth, and we can see that the earth's gravitational field is causing the moon to accelerate or to move towards the earth, whereas the moon's gravitational field is causing the earth to move towards the moon. So we can say that because of the Newton's third law of motion, the force from earth to moon, if that is the action, then the reaction is the force that pulls the earth to the moon. So we can say that F of g is equal to me into mm. The mass of the moon and the mass of the earth is inversely proportional to the squares of the distances between them. Now this force, it acts along the line joining the two objects. Now this Newton's universal law of gravitation, it is applicable to satellites of other planets as well. It is independent of the intervening medium. Irrespective of the medium, this holds good. Irrespective of the nature of masses, the changes in the temperature, the changes in the pressure and other physical conditions. The law is valid for small as well as large masses, and also it is valid for distances. Now the law holds good for celestial bodies as well. Now since this law holds good for almost everything, now this is called as an universal law. Now we will try to understand the concept of gravity near the Earth's surface. For this we got to understand the concept of weight. What is a weight then? For example, when a man stands on the surface of the earth, the man's mass, it exerts force on the earth. Now, as per the Newton's third law, the earth also exerts an equal and opposite force on the man, and we also know that the earth's force, it always tries to pull the object towards its center, and therefore the man feels weight. Now, in the second scenario, it's so happening that a man is allowed to have a free fall, or he could be coming down in a lift from 10th floor to the first floor. Whenever an object is freely falling, it does not exert any pressure on anything. So there is no action happening over here. The action is equal to 0. There is no action happening over here. When there is no action, then obviously there is no reaction. It means that when the man is not exerting any pressure on anything, so earth also is not exerting any pressure, either equally or in opposite direction, on the man. So it means that there is no pressure acting on either sides. So that is the reason why he feels weightlessness. So we can come to a point stating that when an object is at rest on the ground, for example, if the man is at rest on the ground, if the object is at rest on the ground, they are constantly being pressed against the ground, which for humans creates sensation of weight. However, when the group of objects are all in a free fall together, they are weightless relative to each other. Now this explains the concept of weight and weightlessness. Now let us go and understand what would be the variation of acceleration of gravity when the object is at a distance h from the surface of the earth. Now if a body B, for example, is at a height h above the ground, then the gravitational force is nothing but it is directly proportional to the mass of the object and inversely proportional to the square of the distance between them. Now in this case, it does not consider the mass of the object, it considers the mass of the earth. In this case, it is me. Distance d is given by the radius of the earth, that is the distance from center of the earth plus the height of the body from surface of the earth, that is h, and it is inversely proportional to that with the square of the distance. Mass of the body is immaterial. There is something called as gravitational constant also, g. So we can state that the acceleration due to gravity at a distance h is equal to g into me divided by re plus h whole square. Now from this we can infer that the value of g is independent of the mass of the object. Here nowhere we are considering the mass of the object. It depends on the mass of the earth and the distance of the object from the center of the earth. A simple consequence of this is the variation of g on the earth itself. Now it has been experimentally verified in this case that the value of g is slightly higher. Now if you take at the poles of the earth, the value of g is slightly higher than at the equator. This is the equator passing, and the value of g is slightly higher over here than at the poles. Now that is basically because of the geoid shape of the earth. Next, let us understand the motion of the planets around the sun. For this it is important for us to understand the concept of Johannes Kepler's laws. Now the Kepler's first law states that the planets move in an elliptical orbit around the sun. This is sun over here. The planets are in an elliptical orbit around the sun with sun at one focus. The position of the sun will not change. The first law. The second law states that if an imaginary line from the sun to the planet, for example the planet is over here, then this imaginary line, it sweeps equal areas in equal intervals of time. That is, if a time is t, in this case the distance travelled is of this, as well as distance traveled is this is almost the same. It doesn't change. Now let us read. Let me read it for you. The planet moves moves distance x. This is distance x. This is distance y. The planet moves distance x and distance y in the same amount of time. The time taken to cover this distance from A to B and C to D is same. That means that this area x is equal to area y. But the planet moves fastest when it is near the sun. If it is near the sun, it moves the fastest, because we have studied that in case of gravitational force, force is inversely proportional to the square of the distance. Let us try and understand the third law of Kepler. The third law of Kepler states that the cube of the average distance of a planet from the sun, if this is the distance r of it, is directly proportional to the square of the period of the revolution. If period of revolution is t, then r cube is directly proportional to t square. Now, if we apply the same equation, that is, r3 is equal to t square, this is Kepler's third law, to the earth and the planet, then we can say that re3, that is planet will take it to rp3 divided by re3 is equal to tp cube divided by te cube. Now we know that an astronomical unit is equal to 1.5 into 10 raised to 8 kilometers. Now if I substitute that over there, that is, I get rp cube is equal to tp square. I substitute re3 by tp by te cube. Te square is equal to 1.5, that is 1 AU astronomical unit divided by 1 year square. So I get this as the Kepler's equation. Kepler's third law is basically used to find the mass of the sun, the distance of the planet from the sun, and the period of the revolution of the planet. Now Newton showed that the Kepler's law could be derived from the universal gravitational law as well. That is, now we already know that centripetal force is equal to mv square divided by r, and gravitational force is equal to g m into m divided by r square. Both are same. Centripetal force is something which pulls the object towards center, where gravitational force is also the same thing, in which case the earth pulls over towards center. If we apply same thing over here, then we can derive the third law of the Kepler again. We know that V is equal to 2 pi r divided by t. We have studied this case of an object that is held by the hand. The string is over here. If you rotate it in this direction, the object continues to move in this direction at velocity v. This is a distance t over there. Now this is a circumference, that is 2 pi r. So it is 2 pi r by t. So therefore we can say that r cube, by substituting over here, we can say that r cube is equal to gm divided by 4 pi square. It's 4 pi square into t square. This is nothing but again a Kepler's third law. The Newton used this Kepler's laws as an evidence for his law of gravitation. Now finally, let us come to understand what is the importance of these laws of gravitation. Now, the laws of gravitation helps us to know about several phenomena which were believed to be unconnected. The first thing is we got to know that there is a force that binds us to the earth. We got to know about the motion of the planets around the sun. We also got to know that the motion of the moon around the earth. We also got to know the reason for the tides due to the moon and the sun. Thank you.